I received a request from a viewer that wants me to solve this Bernoulli equation. The equation that he wants us to solve is x dy dx plus y is equal to minus 2x to power 6 y to power 4. We know that the general form of Bernoulli differential equation is dy dx plus px y equal to qx y to power n. This is the general form. So let's go ahead and write this in general form. So we have to get rid of the coefficient of dy over dx. So let's divide both sides of equation by x. So if we divide both sides of this equation by x, here we are going to have dy over dx plus 1 over x y equal to minus 2 x divided by 6, x to power 6 divided by x will be x to power 5, y to power 4. So here, this is our px, this is our qx, and this is our y to power n. So in this equation, the value of for n is 4. Okay. So our n is equal to 4. So step number 1, we multiply both sides of equation by y to power minus n. We multiply both sides of equation by y to power minus n. So we are going to have y to power minus 4 multiplied by dy over dx plus 1 over x, y to power minus 4 times y to power 1 will be y to power minus 3 equal to minus 2 x to power 5. So this was step number 1. So step number 2, assume that v is equal to y to power 1 minus n. So y to power 1 minus 4 will be y to power minus 3. So this is our v. Now from this equation, v is equal to y to power minus 3 dv over dx will be equal to minus 3 multiplied by y to power minus 3 minus 1 multiplied by dy by dx. So dv over dx will be equal to y to power will be equal to minus 3 y to power minus 4 dy over dx. So now in here, in this equation, we can solve this equation for dy over dx will be equal to minus 1 over 3 y to power 4 dv over dx. So we solve this equation for dy over dx. Now let's plug that value let's plug that value in this equation. Okay, so if we put the value of dy dx, we put that value, we are going to have minus 1 over 3 y to power 4 times y to power minus 4 dv over dx plus 1 over xv will be equal to minus 2x to power 5. Now, if we simplify this, y to power 4 multiplied by y to power minus 4 is 1. So we have minus 1/3 dv over dx plus that. So let's get rid of this minus 1/3. So let's multiply both sides of equation by minus 3. If we multiply this side by minus 3, we are going to have dv over dx, then minus 3 over x v equal to plus 2 plus 6 plus 6 x to power 5. So we multiplied both sides of equation by minus 3. So we are going to have 1 minus 3 over xv equal to minus 2 x5. Now we have transferred this equation into a first order linear differential equation. So in order to solve this equation, we have to find the integrating factor mu x will be equal to e to power integral of px dx, and this is our px. So this will be equal to the e to power minus 3 over x dx, which is equal to the e to power minus 3 natural log of x, which is equal to e to power natural log of x to power minus 3. So e to power natural log of x to power minus 3, so that means the integrating factor mu x is equal to x to power minus 3. So now that we have the integrating factor, we have to multiply both sides of this equation by that integrating factor. So we're going to have x to power minus 3 dv over dx minus 3 x to power minus 3 multiplied by 1 over x is x to power minus 4 equal to 6. X to power minus 3 multiplied by x to power 5 is x squared, 6x squared. Now we can write this equation as d x to power minus 3 v over dx equal to 6x squared. So here, in order to solve this equation, we take integration on both sides. So on left side, we are going to have x to power minus 3 v equal to integration of this side will be 6 x to power 3 divided by 3 plus a constant. So x to power minus 3 v will be equal to 2x cubed plus c. So if we multiply both sides by x cubed, we are going to have x to power minus 3 multiplied by x cubed v is equal to 2x to power 6 plus c x cubed. So these two will cancel out, so v will be equal to 2x to power 6 plus c x cubed. And we assume that v is equal to y to power 1 minus n, which is equal to y to power 1 minus 4, which is y to power 3, which is y to power minus 3, sorry. So instead v is equal to y to power minus 3, so y to power minus 3 is equal to 2x to power 6 plus cx to power 3. Which we can write that as 1 over y to power 3 is equal to 2x to power 6 plus cx to power 3. So this is our solution, or if we want, or we can write this as, or we can write y to power 3 is equal to 1 divided by 2x to power 6 plus cx to power 3 or y is equal to 1 over 2x to power 6 plus cx to power 3 to power 1 3. So this is our solution for this Bernoulli differential equation. This was a good problem. If you want me to solve any other differential equation problems, let me know. I believe by now you are able to solve this type of equations, and I will start in higher order differential equations in my next videos. See you.